everyone. Shyam SK Google. What does that mean, Shyam?
I think everyone's googling it.
Oh, Googling your adjectives. Okay, nice. That's also a good way. Okay, so thank you all for taking up your time for introducing yourself. So another thing I would like to ask you is, okay, someone's using Chat GPT too. Very nice. Okay, another thing that I'll ask all of you is, mm, how many what was your why did you actually join the event? And I'd like to see, this is basically an understanding for me to get to know you all, and to get to know your expectations, uh, so that it will give me more insight on how to take this boot camp forward. So we have a 5-day boot camp, and on this day I'm just planning to start with the basics and get to know your expectations as such. So why don't one of you take the initiative to say, like, why did you join this boot camp and what are your expectations that you want to be fulfilled at the end of this boot camp? There should be some motivation for you. Some of you might be curious as to explore it. Any reason, it's okay, it's valid. You can just speak up. And I don't use ChatGPT to get this answer also, because I want your answer. And those who are not comfortable in speaking in English can also speak in Malayalam. It's completely fine.
Mini project.
Sijo. Hi Sijo. Okay,
I
it's because of your mini project.
Yeah,
You're in S4 right now, or S6?
S6.
Okay. So you're trying to implement your mini project with machine learning.
Yeah.
Okay.
But in fact, Ria, you know that there are many people in this meet.
So, sorry, Varsha.
Well, for a fact that I do know that many people are looking for it.
For the mini project. Okay. Okay, anyone else? I see a lot of first years in the group. So one among the first years, what was your motivation? Hmm, no one among first years now?
Well, Chechi, I wanted to make autonomous surgery robots. To make that, we really need to use computer vision, which is actually a branch of AI and ML. So I joined BTech in CSAI, but I really don't have a deep understanding in AI. So I joined this.
Okay, so have you explored AI before, or is this your first
Yes,
time?
I have briefly, but I don't know much other than NumPy and Pandas. I'm not
Okay.
very well good in math also.
Okay. No worries, we can fix that up. And everything that you need to know is, like, you have to start from first principles and you need to start with the basics. So, first and foremost, we'll just, kickstart into a few things. So, I don't have a presentation ready up and right, because I wanted to talk to you organically and let's figure it out on the way. So, machine learning, as the term suggests, so when you hear about machine learning, this question, Ashwin, I think Ashwin can answer this question first. What was the first thing that you have in your mind? What is the first thing that you have in your mind? Because I'm asking this question directly to Ashwin because I feel that he has explored much. Anyone who has explored it before can answer. Anyone who has not explored it before can also answer. I would like to hear your views.
Chichi, I didn't really get you. Can you ask it again?
So it means when you hear the word machine learning, what is the first thing? What is your view about machine learning?
Ma'am, Chichi,
Just
actually,
you don't have to call me Chechi also. Ria is fine.
okay. In my understanding, it's actually about creating a model which can identify patterns in a given data, in a
Okay.
given data set.
Exactly. That's almost very much correct. So machine learning, as we talk about it, it is a subset of, like, you call it subset, you call it a part, you call it a branch, whatever you can call it, but it is a subset, or it is a part of whatever it is, of a huge domain which we call it as artificial intelligence. So you call it as artificial intelligence, which is the concept of the base concept of the artificial systems that do not have a brain to think like us, those who don't have. So anything that's different, the basic thing that differentiates between a human and a machine is the ability to think, or to be conscient of its surroundings, to check out its surroundings, and to be to respond to it accordingly. That is what you call it as consciousness. So, consciousness is the most decreeing property that actually differentiates between a human and a machine. So, if you give this ability to think to for machines, that is, and they can act accordingly as a way as a human response, or as an intelligent individual response to a situation, that it's what you call it as artificial intelligence, providing intelligence to artificial things in basic terms. So this artificial intelligence, it is actually a broad domain, and you have a lot of different subdomains that comes under it, and one of which is actually machine learning. There are other domains that you call it as knowledge based systems. There are other domains that deals with emotions and sentimental classifications, a lot of things. And machine learning is basically uh, the subdomain that actually brings in the idea of giving this, or teaching a machine to respond to a situation, or to respond to a particular problem, or to respond to a particular scenario. So as Ashwin had suggested, what you need is, you need, as much as you teach a kid, as you teach a kid, imagine that you yourself are a parent and you're trying to teach your kid about what is good and what is bad. So exact, and how do you teach your kid? You sort of give examples of what are the good things, and he should learn this, and if he learns this, he'll achieve more good in life, or he'll get some sort of incentive or a gift out of it. And when you do bad things, what you do, others will talk bad about you, you'll always give the side effects of everything. So you're trying to make that kid understand what is actually good and what is actually bad, and you're providing examples for him to understand also. Either you can give examples, or you can also give experiences, like if a child does a good thing, you can give him a gift. So the child automatically conditions it that if we are doing a good thing, excuse me, I'm so I'm so sorry. Sorry for the interruption. So the child automatically gets this idea that if he does a good thing, he'll get a prize, and if he does a bad thing, he's gonna get punishment. So that's how he learns. So similarly, you're trying to teach a machine of how to identify a particular pattern, such that when it gets this particular when it gets this particular input, it can analyze on its own. Like it doesn't have to follow this n number of steps as you dictate it to it. It doesn't have to follow it sequentially, but it can actually think and formulate its own way of solving that particular problem, or finding the output of that particular input. So this is what actually the basic concept of machine learning is. You actually teach a machine to respond to a particular scenario, or to find the output of a particular problem, as and such. And then what happens is, if you want to teach a machine, either you have to give it written set of instructions. So if you give it written set of instructions, what is the bad point, as you call it, what is the bad point that's going to happen there? So the bad point that's going to happen there is that the machine does not learn, it just blindly follows the instructions. So consider this scenario where, like, you are actually trying to, when your teacher always spoon feeds you with stuff, you don't actually learn things, you are just blindly following orders. So there is no scope of improvement for you people. You're just like going according to that flow, there is no value adding to it. So this particular flow of following this set of instructions is the way how traditional programming works. And when I say about traditional programming, it has got its own league, it has got its own differentiation with respect to, machine learning. So there are two ways where we can actually express this. The first one was about machine learning, and the next thing was about traditional programming. So in the case of traditional programming, what you do is you give a particular set of instructions for a machine. When you code a C program or when you write a Python program, whatever you are doing is you are actually giving a set of instructions for that particular machine or that particular for that particular entity to follow, and then you give an input. The machine process it according to that instruction that you give it, that program that you give it, but it is not learning anything, and finally you get the desired output anyway. But what happens in the case of machine learning, you don't actually give a written set of instructions. Okay, you don't actually give the written set of instructions, but you give scenarios. Over there you give scenarios. So that's what actually differentiates machine learning with respect to traditional programming. Here you have scenarios, or what you call it as examples. So scenarios and examples are the particular things, and as we collectively call, and as Ashwin had told about it to us, we call it data. So to train a machine learning entity or a machine that you're trying to teach, you need data so that it can identify the patterns in that data. Okay. Are you following me till now, or is there any confusion or anything in between? Can you just put a quick show of hands in the chat?
All
Or
clear.
all clear? Okay, sir. Okay. Is everyone comfortable? Like, did you follow it? I'm not going to. Okay. Okay. So, all right. I hope, and I see a lot of positive responses. So I'm just taking it for granted that you are understanding. Not taking it for granted. I'm taking it for myself that you're understanding. All right. So that is about. So I told the story about when you're teaching a machine, you need to feed it data, and this data can be in two different forms. So the first, it has to have the data that you give it for understanding the scenario. So those set of data, you call it as inputs. Okay, so based on these inputs, the machine has to devise, think accordingly, and provide the output. And the results that you get, you call it as the output. Okay, so this is like everyone knows about it, the input and the output part. So what actually happens in machine learning? So the machine is not actually going to, how the machine learns is that it's not actually going to produce an output first hand for this particular input. What we do is we actually feed a set of inputs, and we also provide a set of outputs that are corresponding to the particular input. So the machine sees this particular input and then it sees the output. It sees another particular input and then it sees an output. So similarly, there are a lot of data points like this: input output data pairs. So finally, when the machine sees all these data and it analyzes it finally sees a particular pattern. So this pattern, so the machine's job basically is to identify that pattern in this data. Okay, so once it identifies that pattern, it can formulate an instruction of its own. So earlier, when the programmer gives the instruction to the machine, here the machine actually brings about its own instruction. It actually brings about the algorithm, as we call it algorithm, or the set of steps as to how you can get a particular output corresponding to one particular input. And this part, this process that you call it, we call it training a machine. Okay, so this part of training, please, Iru, you have to keep in mind this particular point. I talked about pattern. Then I'm introducing a new term for you, which you call it as training. Okay. So about training. So this particular period or process where the model actually goes through the set of data, the input output pairs, and then it identifies the pattern, and finally it is completely trained. And when the model is actually completely trained, then you can at what then this machine is actually ready to test itself. And then when you give your output input again, something that you have not given in the something that you're not given in the training phase. So in the training phase you have to clearly differentiate it. In the training phase you give input and the output part, and for when the model has identified the patterns, and when you see that the machine is completely trained, that's when you give it data or input data points that are completely independent of the points that you gave in your training phase. And when if the machine can correctly identify the output of that particular input, that's when you call that the machine is trained or the machine is learned to identify or to adapt to that particular situation. And that process is what you call machine learning. You are not providing instruction to the machine. You're not providing sequential steps for the machine to find this particular output for this particular input. Instead, you are equipping the machine to identify the pattern in the data and develop its own way of finding an output for this particular input. So that is the basic idea behind machine learning. So I've talked about a lot of a few key concepts that are actually involved in machine learning. So I talked about data, I talked about the training process, I talked about the testing process and how a machine finally becomes equipped for you know predicting or finding this output for a particular input. So did you I didn't understand the difference how machine learning is different between the standard or the traditional programming that you do? Only one, others didn't understand? So there are 29 of you in the call, and I can only see about 8 to 9 replies. Hmm. Come on, go on. Okay, so I've talked about the process of machine learning. Now it's time for you guys to think. Okay, all of you guys and girls, everyone, you have to think. You know, you can just imagine situations, or just think of situations where you have seen or experienced machine learning or AI in your life. There are you're all technology users definitely, so you would know things. So you can list them out now.
Face ID, for example.
Face ID. So how do you think? Why do you think that it's artificial intelligence?
Uh,
And
it uses computer vision to identify objects, like to identify it as a human face.
okay, so the machine knows, like it's not fed into the machine that this is how you have. If it's this, it's a human face. No, the machine actually identifies that it's a human face with its own
Ye-
logic, right?
yes, yes.
Yes, that's how it's machine learning. Aditya has commented on recommendation system. Why is it ML, Aditya? Can you comment on that? Okay, Aditya, you can also type it in the chat, your comment anyway. Kevin has made. Okay, first of all, Aditya, no need of ma'am. Anyway, just call me Ria, that's it. It learns from our past experience. That's true. So recommendation systems, in the case of YouTube recommendation systems, if you see, it actually takes in the idea of our previous, the data from our previous searches, the videos that we have watched and everything. And this, the machine algorithm that works behind it takes all these data, and then it suggests, it brings in outputs of, the particular type of, the particular type of video genre that we like and all, and that's how it gives output. So definitely there is machine learning there. Amazon suggestions, another type of recommendation systems. LLMs in chat GPT, definitely yes.
I think a voice to text recognition.
Voice to text recognition, there are two types anyway. There you can also um, write it in, classical programming, where you use Python libraries, but at the same time, the libraries that power that particular instruction does use machine learning. You'll get to know it once you explore more. Self-driving cars, definitely yes. That's the higher form of machine learning, which you call it as. I'll come to that later. Definitely yes. Okay, so thank you so much for all the inputs that you gave in. You guys know, like, what are the different forms. So I can understand from that you guys, are well aware of your surroundings. Friend suggestion in social media apps, definitely the machine is trained in such a way. That's true. So friends request suggestions are also a type of recommendation system. So recommendation systems in general, they work on different machine learning algorithms that the system develops on their own. So we talked about machine learning, and we saw the processes by which a machine can learn, or what is the basic general process of machine learning. Now there are different ways in which a machine can learn. Okay, so whenever we learn for exams, so whenever an exam comes, uh, we feel most of the heat, we feel it at the at the day before the exam, right? That's when we ace through the textbooks, we surf into YouTube to watch YouTube videos, we download all the notes that we can, and we think that we can burn all the midnight oil and learn it the day before the exam. And even, you won't even take your eyes off the books, just at least even 5 minutes before you have to get into the exam hall. I'm speaking this from experience, so you can believe what I say. Okay, so there are different ways in which you can learn. If you learn in different ways, then definitely a machine can also learn in different ways. So what are the I would like to know here, what are the different ways in which you people learn? I mean, how do you learn? How do you learn your subjects for exams? How do you learn different topics? What are the ways that you are you just done by reading notes, or watching videos, or would you like hands-on practice? What is your preference?
Watching videos.
So Sham loves watching videos, YouTube videos. Or do
Yes.
you have specific channels also that you refer to?
No, just YouTube videos.
Okay. Aditya, handwritten practice, very good. Binge watch YouTube. So most of you all are, YouTube fans. Sometimes mug up and then tutorials. Okay. Any other suggestions, girls? Where are you? Where are you? Amanda, have, yeah, YouTube videos plus notes. Okay. So, you don't. Nobody wants a teacher to teach you. By the way, that's not needed. You're all self learners.
In Basilis, no.
Okay. Yeah, that's okay. Okay. Touch. Okay. So you're all self learners. You don't need a teacher to teach you. So, so basically, but still, at some point, you would have had teachers to teach you, right? From your school, when you started your school, when you started your, what do I call it? Baby steps. That's why happen attendance issue with everyone. Okay, so attendance issue is a common problem. Okay. So when you have your baby, when you take in your baby steps, right, you would need someone at a you would have to have someone at a point to teach you. So that's also the different ways in which you can classify the way how a machine learns. So the first one that I would definitely talk about is, having a teacher to teach you. So the teacher would tell you that this is the right thing, this is the wrong thing, and this is how you calculate, this is how you write the spelling and everything. So you have someone who is there to help you with, to tell you what is right and what is wrong. So similarly, that is the case with supervised learning. So as I told you, every machine learning process that you are talking about, you need data. So how can data be the teacher? So that is a question that you have to ponder. So in supervised machine learning, what happens is that whatever data that you provide to the model, right, it will be labeled. It will be labeled as in, so suppose you have a set of data that gives, the rainfall record of a particular uh, of a particular of a particular region. So the rainfall, the humidity and everything. So you have all the data values, and it will be properly labeled that these set of data values refer to the rainfall rate, these set of data values refer to the humidity rate, and the next set of data values, they refer to the temperature. So all of these will be labeled. So I'm just quoting a classic example. So that way the machine actually knows that, okay, what value belongs to which category. And the output also, if you have to predict the amount of, so based on all these all these cases, all these values, you have to predict if it will rain next, if it will rain in a particular time or not. So then, even then, those output values that we give for training, even they will be properly labeled, saying that this is output. So if the case of training a machine happens with labeled data as such, then that you call it as supervised learning. Okay, so that you call it as supervised learning. So then what will it be? Unsupervised learning, can anyone guess?
Maybe the data is not labeled.
Exactly. Maybe the data, it's not, the data is actually not labeled. So there wouldn't be labels like this is rainfall, this is temperature, this is humidity. It won't be like that. So then how would the machine learn? So how would the machine learn? So what happens is that the machine would consider all the data that they have. Okay, all the data that is having, it's not labeled. The machine doesn't know which value belong to which category. Doesn't know. So what it does is that it takes in all the values and it sees, it checks on different similar patterns. Okay, it checks on similar patterns that it can identify. It may be, a particular group of data show this type of similarity, then a particular group of data show this type of similarity, say X or Y. And then when it takes in all those similarity patterns, it then groups the data. It groups the data into different classes. So that's how unsupervised learning happens. Just as you people, shared your experiences learning different things. You talked about watching videos, you talked about, notes and everything. So you're trying to self learn by experimenting different things. Okay, so after what, maybe after watching, 5 to 6 videos, you would have, identified, okay, this is the best video for you. So you are actually trying to find the particular pattern that actually suits you, and then then you decide that this is for me, and you group it differently. So the same way, the machine learning model, how it handles unsupervised data is that it finds, different patterns in that particular data, and then it groups data into different classes. So that's how unsupervised learning happens. Then there is another class that you actually have to think about, which we call it as reinforcement learning. So reinforcement learning is similar to the example that I've quoted in the beginning of the session, like how you teach a child, how a child learns, or how you learn on your how you learn on your own. Like if you think that, if you know that this particular good thing earns you a gift, then you know that it's a good thing. If a particular thing earns you a punishment, then you know that it's a bad thing. So you're actually learning by experimenting. Okay, so you're, so each experience that gives you a positive, a positive point or a positive thing, that you learn that it is something of a good pattern. And then any other thing, these things that give you rewards, you know that it is good for you. And the things that are not good for you, that do not give you a reward, that those things are not the correct way, it is not the correct way to do something. So that is what you call it as learning based on experience. That is what you call it as reinforcement learning. And reinforcement learning, the best example that I can give for you is self-driving cars. So who has, yeah, Anand has actually talked about self-driving cars. So for self-driving cars, they actually take in reinforcement learning. When they go through the path, they hit upon a hurdle and they know that that's not the correct way. That's how they, understand the, they detect the lanes and everything. So that is all about the types of learning. I hope you understood, all of you, the different types of, the different ways in which a machine learns. Okay, so another thing that I'd like you to know, that so we've gone through the bare basics of machine learning, what it is, what are the important things that comes on, what are the different ways in which a machine learns. All of it we went through. So we also talked about the importance of data. And now let's talk about something. So this machine, right, that you are giving this this data this all these data, you feed all the data, and you want this machine to identify the particular pattern, so that this machine sort of uh, becomes the Gyani Baba, as you call it, the Gyani Baba. Definitely, Vaishnav, I'm coming to that about semi supervised learning. Yes, this machine sort of becomes the Gyani Baba, where it can actually provide uh, the output for any particular input pattern that you give it. So that machine, or that question answering Gyani Baba, you call it as a model in machine learning. So a model can learn unsupervised, supervised way, in unsupervised way, and also in reinforcement way. But there is also another class of learning, like how do a university student actually learn. So sometimes he gets help from teachers, sometimes he gets, decides on its own, he decides on his own course on how to learn something, or how to, understand a concept and everything. So in this part, you have a supervise, you have some help from someone, and you also figure it out on your own. So in this way, the model that we are using for training, some of it would be, some of the data points that it receives would be labeled. Okay, some of it will get some help, but the other part, it actually has to derive its own way of pattern, and it also has to identify from unlabeled data sets also. So that's what you called as a semi-supervised learning, where it will get some help, but it cannot actually rely on that on the whole part. So in supervised also, there is semi supervised learning, then you have unsupervised learning, and you have reinforcement learning. Semi supervised learning comes as a next step of supervised learning. All right, so that was all about the different forms of learning. And I've also introduced a few basic terms about like input, output. Then how do you know that a model is well trained or well fit? It is the best model. How do you understand? How do you identify that? What should be the basic criteria? So you can think this logically. Actually, you don't have to go too much technically or think too much technically for this. So if you are trying to see, if you know that something is the best, how do you understand that it is the best? Simple logic. If you know that this item is good, how do you understand that this is good?
accuracy and speed.
Accuracy and speed. So, what is accuracy and speed actually? I'm not just talking about the machine learning model, but anything in general. If you think, okay, this particular game that you like it and you know that it is the best, so how do you know that it is the best? No, don't think so high level about minimum error. Like you will have some set of quality standards for it, right? Exactly, it suits the person. So whatever similarly, whatever machine learning model that you train, it has to suit the particular use case for which we are training it for. You need to have some set of excuse me. Okay, you need to have some set quality standards, or what you call it, measures that actually enable you to check into that this is actually a good model or this is actually a better model. So those measures actually help you to identify the the quality of the model. So such measures that you call it as, in machine learning you call them metrics. There are a lot of metrics that actually helps you identify the helps you describe a model, and one of them is actually what Ashwin had told, the accuracy. The accuracy with which a model gives its predictions. So how do you calculate the accuracy? It is like you already have, so you will be training a model with supervised learning. So accuracy comes in the most way for supervised and semi supervised models. Okay, you cannot actually talk about accuracy in unsupervised and reinforcement, but you have other ways of measuring it. But specifically for supervised models, you can actually talk about accuracy. So you will have this training pattern for data, right? Will have this training data, and you always have the set of inputs that are mapped to a certain set of outputs. So you actually take a part of the training data, okay, and the other part, a part of the data you take it up and you move it aside, and the other part, the bigger part of the data, you use it for training your model. And when you use it for training your model is actually trained, and then what you do is you take the part of the data that you've kept away, and you're gonna take only the inputs from there. You're taking the inputs from there and then you're feeding it to the model. Okay, so what do you have right now? You actually have uh, the set of outputs for these particular inputs are already ready, and then you are actually giving these inputs to the model to test. And so the model will give particular outputs for all the different inputs that you've given, and then you actually have to check whether this predicted output from the model actually matches the actual output that you have, the target values that you have, and the predicted values of the model, which we call it predicted values as such. And then these output values, we call it as target values. Okay, you have to check the difference between the target values and the predicted values, and if you see that there is not much difference, or it is the predicted values are almost similar or even similar to the target values, that's when you know that the model has a very high accuracy, or the model is really best fit to serve that particular use case for which that you use it for. It may be to predict something, it may be to classify things, as classify things into apple, orange, banana, whatever it is. So it may be for any particular use case, any particular domain. It may be rainfall, it may be marks, predicting the marks. So any particular use case, if you think this is the process by which you actually check whether the model is actually suitable for the particular use case, and only then, only after testing whether it is particular for this use case, only then you can actually use it for real world processes. Okay, you cannot take any airy wary model and straight away go and deploy it. No, you cannot do that. You actually have to test it and ensure that it meets the particular set of metrics that you want to the particular set of quality standards that you want to. So I've talked about accuracy today, and as you know, the day progresses on, as the bootcamp progresses on, we'll actually talk about, we'll actually look, not just look, we'll actually see how quality, how performance measures are actually done for machine learning models. Okay, so that's about accuracy, and I talked about training the model. I talked about the terms like predicted values, target values, input, output. So I want all of you to actually, make a mental note of all the terms that I'm mentioning, and you have to check after the session gets over. I'd like you to check it out and see. Search in ChatGPT, you'll get the best answers. Search in Google, you'll get, ChatGPT is like your supervised learning, and you searching in Google is actually your unsupervised sort of learning. Okay. No, you searching in Google is actually semi-supervised, because you actually have to pick which is the right thing for you also. So it's not exactly unsupervised; it's semi-supervised. All right. Okay, so that's all about a lot of. I've mentioned a lot of. I've been talking for a long time. So are you guys getting bored a little bit? Shall I stop? Okay. Okay, only a few know. I think all the others are getting bored actually. Is everyone here, by the way? Okay, thank you, everyone. So I've talked a whole lot about, I've given a very good intro, an okayish intro, not a very good intro. I think we can all have scope for improving. So I've given an okayish intro about machine learning. Now I want to introduce you to the three things that you need to know whether you're learning anything. Okay, if it's machine learning, whichever domain that you're into, you actually need to have three things. So the first one is base. Base would be, you need to actually know what exactly that particular thing is. If you are knowing about web development, you need to know what is web development and why is it used for all the important points. Then the second thing is, you need the right tools. Okay, you need the right tools to, you know achieve what you want. And the third thing that I would actually stress upon would be logic. You should have your own way of thinking, of solving your problem and everything. So together I call it as the BPL of learning: the base, tools, and logic. So we've actually gone through a lot of things that generally a beginner in machine learning should be knowing: the processes, the terms, and all those things, the different methodologies and everything. So now we are actually going to get into tools. Okay, so which language, those who know about machine learning, which language do we usually use to code ML problems?
Python.
Python. Any other language that we use? Aditya told about R, definitely. R is. Anything else? So I'm not sure if you know about this, but we can also code machine learning problems or machine learning models using Java. It might come as a surprise, but it is true. You can actually, and people, most of the traditional systems in machine learning, before Python was actually, before Python was actually invented, with ML systems used to be coded using Java. So Python, when Python came up, a whole lot of the processes became so easy, because Python has this whole set of machine learning libraries and everything that you can just, you can use it like a drag and drop. But when you used to do it in Java, the library support was comparatively less. And then you had to write a whole lot of logic by yourself. So that's how Python, when it came up, it came up as a blessing for ML developers. Okay, so you definitely need to have a command on Python. I mean, you don't have to be a very good expert, but you just need to know Python programming. So how many of you are familiar with Python? Oh, Sham needs to work on Python. Okay, it's fine. It's fine. Even if you don't know Python, having a knowledge about Python would definitely give an add-on bonus point. But even if you don't know, what you can do is you can try. Uh, I have a very good Python tutorial that I can suggest. You can watch it side by side, and try and have a grasp with Python. You can also whenever we are going through code or whenever we are programming along with for this bootcamp, you can just follow along that also and try and understand the concepts. That would also be fine. So but as and such you go forward, and when you actually start developing ML models, you need to have a strong command on Python. Okay, so having Python is very very important. And another thing that I would suggest you people having is that a good code editor. So uh, there are different types of code editors. We have VS Code, where you can actually do VS Code. Yes, you have Atom, you have Vim, you have Sublime, a whole lot of code editors. So when you're actually trying, even if you are developing an ML model, ultimately what you have to do is you cannot do anything with the ML model as such. You need to integrate it into some sort of application. You need to have a front end and a back end running, and to which you have to integrate this model. And then you can then equip the user to use it. You cannot actually ask the user to work with the ML model as such. We need to have an interface for the user to interact with. So the code editors actually help you to develop that part. To develop a website or to write your logic in backend and everything. You can use code editors, but when you are actually uh, developing models, you need to have step by step testing as to which logic is best for, or which amount of parameters, or which way is the best way to develop, or which uh, parameters actually give the model the correct aspect to predict, or at which stage is the accuracy of the model best. After how many training periods does the model gives correct accuracy, does give the correct predicted output. So all these factors you have to consider, and doing it in a code editor, you can definitely do it, but it is actually a whole lot of time consumption. And that's when these things come into play. Like, you have interactive Python environments. An interactive Python environment that you actually call it as, or you can even call it as IPython notebook, whatever you call it. You call in basic terms that you call it. You call it the notebook environment. Ashwin has called it correctly. We are the Jupyter. Aditya, I'll come to your query a bit later on. Okay. So Ashwin has actually called it correctly. It's called the Jupyter notebook environment. And there are a lot of services that actually give Jupyter environments. So Jupyter environment is pretty much simple. It is actually this interface. Can you see it, by the way? My Okay, just give me a second.
No.
Give me a second. I'll go back to it. Oh, but now?
Yes,
Yes.
yes.
Okay. Okay. So this is what you call it as a Jupyter notebook. So it has got cells, and each cell actually acts as a Python environment, interactive Python environment. So whatever code that you write in, so if I give it this command like print 5, that's in Python. So you print it. There is 5. So this is the basic thing of a notebook environment. Okay, and then you have different type of notebook environments. So the first one is about Jupyter Notebook, and Jupyter Notebooks, the thing about Jupyter Notebooks is that you can even host it locally. Okay, you can even have it on your computer, and then you have this type of environment where you can run these type of notebook files in the cloud. Okay, in the cloud, as in any company might provide services that actually acts as Jupyter Notebooks. Okay, and Google Colab is an example for that. So Google Colab, it is another interactive notebook environment that provides the same interface, same, you have the cells like this, and you can run your Python commands in it. So that's how you can either use Jupyter Notebook or you can use Google Colab, as in your preference. But personally, I love using Jupyter Notebook because it gives me a whole lot of freedom, and I'll come on to the different ways in which you can use a Jupyter Notebook. So another thing, yeah, in the case of GPU support that is coming in, that comes in when you actually move on to higher models. Okay, but when you're starting up, it is better to start with Jupyter Notebooks, because it will actually give you the processes, gives you the idea of processes of how you can actually develop it locally. All right. Okay, but and definitely there is this point when you're developing ML systems, it is very much computationally intensive. You need to have good GPU, good computation power, and everything. It's really important. So otherwise, your models can drain a lot of power, and it can I've trained a model that actually uh, you know took me about 4 to 5 days to train it completely, and my system was actually continuously working for those 4 to 5 days. I couldn't shut down my system. Yeah, that's right, 4 to 5 days. And there were models that even took about like 18 to 19 hours. Like, that depends. Like, a whole lot of recommendation systems that you find it deployed in different sites, right? They all of them take about a lot of time training, and they even train parallelly while they are deployed also. So that is how machine learning systems work, and it is training a machine learning model. A proper real-time machine learning model is very much computationally very much intensive. So you have to make a note of that. And yes, you need to have a GPU support everything as you need it. So there are two ways in which, so having a Jupyter notebook, you need to how you can do it is that Anaconda is my favorite distribution that provides resources for machine learning and data science related operations. So for Anaconda, you can actually go there and download this in your system for Windows, for Mac, whichever OS that you use it. It's completely flexible. So here you actually have Jupyter, and it gives a lot of toolkits. You have a Jupyter, you'll get a Jupyter notebook environment. You have Jupyter Lab environment. You have Spider. You have Orange. A whole lot of services it provides you. Yeah, I've actually given it in the chat. Anaconda.com. You can download it. If you don't have to download it, and recently Anaconda have also started this their own cloud service, where they provide the Jupyter notebook environment in the cloud. So I've actually, to make things more easier, I've actually opened this in the cloud. What you just need to do is, you just need to if you do start coding now, you need to create an account, or you either need to sign in, and then it's fine, your cloud is actually active. So this is how this is what you call it as a Jupyter Lab. So if it is individual Jupyter notebook, it will be just like this. You will just see the notebook as such only. But if it is a lab, if it is a Jupyter Lab, you will have the exact experience as you have when you as in an editor, as in a code editor. You'll have a side bar where you see your your directories, your notebooks, and everything, and you can actually keep on navigating between things. So things, your life becomes pretty easier in that note. All right. So that is you. So I would like you all to have an Anaconda distribution installed in your system, and you need to have Python installed in your system. So make sure that before tomorrow's session, you have both of them installed. How many of you have both of them installed? Anyone? Pavitra and Aditya, you don't have Python in system. Okay, no worries. All you have to just do is go to python.org/downloads. I'll post this link also. And you can directly go to download Python 3.11.4. That is the stablest release as of now. So you can download it based on your OS, and then you can download Anaconda over here. Or if you are not comfortable working with Anaconda in your system, you can also try it in the cloud. It's perfectly fine. But I would definitely encourage you to download it and install it in your system, so that it will always be helpful in future also. Like when you're developing, especially for those who are developing your projects, this is a very good toolkit that you can use to develop your own thing. And a quick tip for Wesalians: we already have a very good computationally intensive system in our knowledge lab. So anything that you develop on your computer, if you want to train it, you can actually take it there and train it. So it's actually possible. Okay, so that is all about the right tools that I've mentioned. Then there are a whole lot of machine learning libraries that you can be familiar with. That actually makes the life of an ML developer easier. You have NumPy and Pandas that are used to handle data. They make your data so structured that it is easy for an ML model to read through it. So that's how NumPy and Panda are usually for data processing. Then you have Matplotlib and Seaborn. You don't have to worry about the names and terms. I'll soon be sharing a document with you all where I have written all these details properly and effectively. And you can also note down these terms and Google it or use ChatGPT, so that you'll have more info about it also. So that is the best way for which you can learn. Like pick up the terms that I'm mentioning and search about it. So Matplotlib, Matplotlib. So I've told you about NumPy, we talked about pandas. Both of them are data processing libraries. Then you have Matplotlib, then you have Seaborn. So both of them are data visualization libraries. So if you want to identify how much what the structure of your data, identify different patterns in your data, and then you have to actually think about which model will actually work well for this data. So this part is what you call it as data wrangling or data cleaning or data analysis. So for that, you need these libraries where you can visualize the data as charts, as pie charts, as bar graph, as line graph, all those things. And that's how Matplotlib and Seaborn helps you. And for classical machine learning, we have a whole lot of algorithms. We have different techniques of machine learning. It could be prediction, it could be classification. All of this comes into the picture. And this particular framework or machine learning library, which we call it as scikit-learn, it is a very useful toolkit library because it has a whole lot of machine learning algorithms coded into it, and you just need to pick it up and fit it into your code. So scikit-learn provides a whole lot of machine learning libraries as such, and for easy to use. You don't have to actually code the algorithms from first hand onwards. The library actually provides you all these algorithms just to use it in your code. So scikit-learn is a very important thing that a beginner should know about. So we'll be we'll be mostly working with these 5 libraries in our bootcamp. And we'll also, by the end of the bootcamp, we'll also check into deep learning, where you can actually check into how you can detect images, how you can generate next text, pieces of text from the previous set of words together. What you can actually predict what the next word is. So all of these comes into very specific forms of machine learning, and we'll also check into the future of whatever you can explore also. And coming back to Aditya's question, we can deploy a model like on Heroku. Yes, you definitely can, but you are not going to deploy a model as such. You need to have a little bit of logic written as to how inputs should be taken and then how it should be fed into the model. You also have to collect the output that the model gives, and then you have to give it to the interface. The interface is just as simple as it could be a small website or an app, whatever it is. You just need to provide a space where a user actually can, provide his or her input also. Or it could even be from command line. If you are using from command line, it's fine. But if you actually have to, deploy your model for someone else to use, you have to connect it to an interface, deploy it on any cloud platform, like any deploying service like Heroku, or it could be Wordcell, anything. You can deploy it so that it's ready for use. Or you can even self-host it. There are self-hosting services like DigitalOcean that helps you to self-host your own code. So I hope I clear your query, Aditya. Aditya, is it okay? Was it okay? Was your doubt clear? Okay. So I think that's enough information overload for today. So we've talked about the basic intro of machine learning. We talked about the different methods of machine learning, and we talked about the different tools and toolkits that you should be having so that you can develop and play with machine learning models. We also talked about a few libraries that we'll be touching upon throughout the bootcamp. And and we also, I am giving you my best wishes for the bootcamp, and as and such, I hope that I have your wishes with me also, so that together we can sort of have a peer learning format that will benefit all of us. As much as it benefits you, I hope it benefits me also. And definitely, I hope to see you all forward. And anything that you would like to share at this point? This Figma file, okay, definitely. But there is nothing much, but still I'll share it.
Just letting everyone know that we have recorded the session, so we will be sharing the session recording to all of you via your mails. So, yeah.
All right. Anything that you'd like to speak up, peeps? Like, how was the session? Anything that you'd like to improve? Anything that I should take care of in future while we go through the sessions? Is this bootcamp connected to the TechnoVerse hackathon? Yes, in a sense, but still, you can actually pick up inputs that you find in these set of bootcamps, and then you can work on your hackathon project. Like if you are basically trying to make use of a machine, develop a project that links with machine learning, then you can. If you are not someone who is familiar with machine learning, then you can take inputs from these sessions. Similarly, you have web and blockchain also. Again, Karthik, avoid the ma'am. Just call me Ria. All right. Anything else that you'd like to ask anyone? How was the session, by the way? I'd like a feedback also. Anything. It could be you need to increase your speed. You need to tone down your speed. You need to work on your language. Anything. Criticism is also okay.
At one point, it was a little confusing.
Okay.
Yeah.
Which point?
I think the predictive values and stuff.
Okay. So basically,
That's
you
it.
just need to check into this. Like, whatever the model gives you as output, that is the predicted value.
Okay.
And whatever you would have some set of values that you feel it's the actual output. Okay, that is what you call it as the target value. So this concept won't come in the real world scenario. This will only come in the training part. So
Okay.
all the labeled data that you have, if you're using it for training, right? So you won't take the entire data to train your model. You will only take the majority part to train your model so that the model identifies the relationship between the input and the output. Then you will have the latter part of the data that you have not used to train your model. But what do you have here? You have the input and the corresponding set of output also. That output you call it as target values. So ideally, the model should be predicting values that are closer to that or that are absolutely similar to that. You give all these input values of that corresponding target values to the model, and the values that the model predicts for those input values, they are the predicted values. Then you compare between predicted and target values. Have you got it?
Okay.
That's when you the difference between those values, right, when it becomes so minimal, and the difference between those values is actually called as error. Someone mentioned about minimal error. That is this is the concept of error. So the difference between the actual and the target value and the predicted value gives you the error. And when the error is very much minimal, that's when you say that the model has high accuracy.
Okay.
Okay, so now it's time for your homework. Go home. No, you're basically at your homes right now. So I just got into the flow. I'm sorry. Okay, so you can take your time. Those who don't have Python installed, please install Python. Please also check out and install Anaconda distribution and see what are the different toolkits that are available. There is Jupyter Lab, there is Jupyter Notebook. I personally prefer working with Jupyter Lab because you have you as I just showed you the interface, right? So you have a directory set up on the left side, and here you have your code. You can work on it. So you have the proper editor set up in Jupyter Lab. So that's it. That's it for today. Anything else that you would like to share upon? All,
I
all
think
right,
that's pretty much
everyone.
it, right,
All
Ria?
right. Yes. So these were the things pretty much that I wanted to cover for the first session. You need to have a good start on the concepts, on the tools, and the correct ways of learning. Okay. There are no, okay, whenever you're trying to learn something, there is no right way or the wrong way. It is just the way that is suitable for you. You have to understand that. So I cannot actually suggest you, I cannot actually tell you that this is the right way or this is how you should follow. No, I can only speak about my experience, the mistakes that I did, and the insights that I found. So you have to take in these points and design your own way of learning, of knowing a particular stack, whatever stack it is. It could be web development, it could be blockchain, anything. It would be machine learning, but you have to create your own model. So this is my parting message for today.
Yeah, so I think that's a great message to end with, and hope to see you all in the upcoming session as well. And we'll be sharing the details of the upcoming session via mail as we did for this session. And once again, thanking all of you for joining in today, and especially our speaker, Ria. Thank you so much for such a great session. You kept the session like, throughout. It was really engaging, and you did cover a lot of topics today. And yeah, thank you so much. And thank you to all the participants. And as I mentioned earlier, hope to see you again. And yeah, so I think this is it. For now, you guys can leave the meet. And bye bye. Good night.
Thank you, everyone. Thank you so much, and I hope to see you all in the upcoming sessions.